In this video, we are going to continue on our quest to separate things, and we will go one step further and separate our interface across multiple interface files. This is something you may want to do if, for example, you are developing the same module, but it is a team of people that are working on the same module. So person B is working on another part and they need to put everything together. You can use this technique to put your code together. Let's look at the code because that's the best way to explain these things. Again, we have the same module we've had before. We have our declaration here. We have our purview. We have our preamble down here, and we have our purview, which is going to contain the interface that makes up this module here. We have a bunch of functions and we have a class. Now, what we are going to do is to separate this into two implementation files. The first implementation file is going to contain math-related stuff. That's why we call it math_impl. And it is going to have the add function and the definition for our point constructor here. Notice that it is the same old structure we follow. We have a module, we have the module declaration, which is really not a declaration here because this is an implementation file. So all this line is saying here is that this file is part of the math stuff module interface. We have the preamble. If we wanted, we could import stuff here, and we have our implementations that make up the purview of this file here. We also have another file which is going to contain print related stuff. Again, we have a module, we have the declaration, and we have our purview. And it is going to contain the greet function and the print name length function here. And using this technique, you can have as many implementation files as you want. That's going to depend on what you are trying to build with C++. Now that you have seen this, let's head over to our IDE and see this in action. Okay, here we are inside Microsoft Visual Studio, our IDE. The code we will be compiling will be coming from the GitHub repository. The current project is 48.6. right here. So these are the files that make it up. We have a main CPP file. We have our interface file. We have math_impl and print_impl as our implementation files. These are the files that are going to make it up again. And these are the instructions we will be using to compile on Visual C++. Visual C++ is going to give a nice experience in that you don't have to compile yourself. The tools are going to take care of figuring out the dependencies and compiling our module files in an order that will make things work. For GCC and Clang, the story is different. We have to compile ourselves, and we have to make sure we compile things that other files depend on first. That's why we compile the IO stream header unit first. After that, we do the module. After that, we do implementation files. And after that, we put everything together. The same story applies to Clang. So you can see that we are compiling the header unit first. We do the module files. We do the implementation files. And then after that, we put everything together as we do here. For Clang on Windows, we don't pass this flag because we don't want to use the Clang standard library, but on Linux we make sure to do this. This is something we have done a lot of times. Take a moment to notice the commands we use to compile here if you care about this. This is something that confuses a lot of people. I had to do a lot of research to put this together, and you can learn from this and adapt this to whatever structure you have in your project if you want to use these kind of things. Let's hop over back to our IDE and add in the files that we need. Let's click and add a math. What did we add? Source.cpp. We don't want source.cpp, but we can rename this to be math_impl.cpp. This is going to do. Let's add another one. So let's add a new file. It's going to be a CPP file as well, and it is going to be print_impl. I think this is the name we used. And we need to add our interface file. Let's do that. Add new item. It's going to be a module file, and it is going to be math.ixx. Now we have the files that we need. We can hop over to the repository and grab the interface file. That's where I like to start. We can copy raw file and come back to our editor, do the interface file. So copy and paste. This is done. This is a module file. We have to make sure we have export module and all this syntax that we have here. Let's go back and do math impl. So it is opened. We can copy raw file. Let's come back, math impl. That's the file of interest here. Let's go back and compile print impl and copy. It is copied. Come back and put it in print impl. It is a module implementation file, and we can hop over to the main CPP file and put in the content. So main.cpp, it is going to import the module and use it. Nothing special here. Copy, it is copied. We can come back and put in our code. Now that we have this, we have to make sure to enable C++20 before we try to compile. Let's go to language here and enable C++20. And we need to come into general here and scan the sources for module dependencies. And we say yes, apply, okay, and try to build. Let's see what we get. Seems like the build is good because we have succeeded here. But again, notice scanning for dependencies. It is going to look at what files that we have. After that, it is going to start compiling. Notice the first thing we compile is IOStream because it is needed by other files that depend on it. After that, we have math. After that, we have our implementation files and the main CPP file. And we can run our application by going to debug and start without debugging. And we will see our output here. This is how you can separate an interface into different implementation files. We have compiled using the IDE from Microsoft. Now, the next thing we want to do is to compile using the other compilers, namely Clang and GCC. If you don't care about that, you can move on to the next lecture, but I strongly encourage at least to watch how these things are done because you may need to do this sometime. You never know. Let's go back to our repository, the README file, and we are going to compile with GCC first. Again, we can learn from the compilation order we saw in the IDE and follow that order. You can pick and cheat and learn. There is nothing wrong with that as long as you don't steal other people's work. So let's go to PowerShell, do ls, and see the content. Again, the meat of this project is this set of files that you see here. The rest that you see on top is just a noise from Microsoft Visual Studio. And we will ignore this for the moment. We will be compiling using G++. Let's put in the command to compile our header unit. It is going to go through. We can compile the module file. We steal the command to do that. And we put that in place. We grab the command to compile our math impl file. This is going to compile it into an object file. We also grab the command to compile the print impl file. And we will put this in place. And you can do ls at any point to see what was generated by the command you just run. And I am going to grab the command to compile everything into the rooster binary that we are waiting for. And if we do that and do ls, this is going to show our rooster file that was generated. And we can run it, rooster, and it is going to give us the output here. This is how you compile using GCC on Windows. Let's use Clang on Windows. Again, this seems repetitive, but you may need to do this. And I want you to be able to adapt these commands to do whatever it is you want to do. If you don't care about this, feel free to move to the next video. Copy the command to compile our header unit. But before we do, let's clean up the mess we left from GCC. So remove the GCM folder, remove any object files that was generated, and remove the rooster binary. If we do ls, we have our starting files here. Let's go back to the command prompt because we are using Clang on Windows, and this is going to generate it. Again, copy all these commands. Bear with me, this may be boring, but it is what we need to do to understand these things. Put in the command. Grab the next command, which is going to compile the implementation file for math impl. Let's do this. This is going to compile. Let's grab the next command to compile the print impl file into an object file. I put it in and hit enter. Let's grab the next command, which is going to compile the main file into an object file. So you can do this and it is going to go through. And let's grab the command to compile our module file into an object file. This is what we need to do here. And we grab the last command, which is going to compile our rooster binary by putting everything together. Let's do that. And we have our rooster binary. ls is not going to work because we aren't on PowerShell. But we have our rooster binary generated using the Clang compiler on Windows. Let's run rooster and we will see the output that we expect here. I couldn't stop without showing you how to use Clang 18 under our Docker container. So let's clean up the mess that was left in by Clang on Windows. Let's remove any PCM files, remove any object files, and remove rooster. Once we do that, we will have a clean slate to start by, and we can copy the commands. Again, I will be copying the commands and pasting them in. You can follow along if you want, or you can just watch me do this. It's also helpful. So let's put in the command to compile our header unit. Let's put in the command to compile the PCM file for our module file. The next command is going to be to compile our math.impl file into an object file. Notice that for Windows, we are using the C++ standard library that comes with Clang. We do that through this stdlib setting here. Make sure you see this. And if you don't understand this, you can search this flag and you will have more information on the internet. You are a good C++ developer if you made it If you made it this far in the course, congratulations. We compile our main.o file and we compile the module file into an object file before we put everything together to generate our rooster binary. So let's do that. Copy and paste the command to do that. And now we should have our rooster binary. Let's show this in a nice list. We can see our rooster binary right here, and if we run it, it is going to give us the output that we expect. This is really all I had to share in this video. The main point is that you can separate implementations for your interface in separate files. If you want to compile this on different compilers, these are commands you can use. Please feel free to adapt them to whatever you need. I am going to stop here in this video, and I will see you in the next one.